All right, good afternoon. Today is class 5 of FOP. We're going to be continuing CRUD applications and picking up from where we left off at the end of last week. I'm sorry, my kid's screaming in the background. Stand by. Okay, sorry, I had to yell at his mom to get him. But yeah, so we're gonna pick up from where we left off. On Friday, we were discussing the to-do list. Once I assigned you guys the assignment, there seems to be some difficulty uh on it. I know it was kind of like throwing you guys into the deep end of the pool. Did I would say a thorough walkthrough very quickly due to the lack of time. And then we assigned it for the rest of the weekend. Now, before we decide to do what we're gonna do next, I want to open up the floor to give you guys the time to demonstrate anything you guys might have worked on if you did. If not, would you guys prefer to take some time before we continuing on to uh, give the to-do list assignment another 15, 20 minutes of time? What would you guys prefer? Do you guys work on it or do you want to work on it now? It's gonna be the only assignment that we do for the CRUD applications. After this, we're gonna be moving on to the Python crash course. So it's either now or never.
I'd say I'm probably indifferent. I didn't actually work on it over the weekend. I was working on a few other things, but at minimum, if we could do kind of like a walkthrough of what the assignment was and the, I guess, desired outcome, that would be awesome. But I don't want to take away from anyone else if anyone else wants to work on it.
What the rest want to do? I need some feedback here, guys. Typically, I'm okay with no feedback, but I'd like to
Yeah,
know
I'm
what.
cool with just doing a quick. I'm cool with doing just a quick walkthrough.
Okay, Sam. All right. We'll
Yeah,
do.
same. Just quick walkthrough because
Okay.
I didn't go to class, so it was a little bit hard to look at the video and try to do that stuff. So
Yeah. All right. So I already have it pulled up. So can you guys see my screen? Now I did deviate a little bit away from the assignment. So if you guys recall, this is what it looked like. You guys were supposed to create a somewhat very uh, caveman style form of a CRUD application with the abilities of reading, updating, creating, and deleting items out of your to-do list. Uh, so the end product should have looked something very similar to this. Which why I really wanted to give you guys some time to see if you guys can create this, uh, which is not too difficult. Essentially, you would just put the initial search bar in the button and a nice div, format it and make it look nice and pretty. Um, the updating of the actual um, to do tasks was the only thing that we did not really cover because we didn't have time. But essentially, you should have been able to click it and it should have scratched it out. Um, but I kind of deviated from that. I did something else a little bit more, uh, how I would say, I was more specific of how I updated. I took updating more of like, I'm gonna change this task to update to new task. But it seems like a more efficient way for an actual to-do list to actually just scratch off the items you've already completed. You should have been able to also delete a task once you want to get rid of it, right? So here is a to-do list. This is my code, what I was able to come up with. We're able to put something like clean room and add it on here with the task and the delete item. Um, Wash the car and complete weekend assignment, right? Uh, the next step was to be able to update our tasks. What I did differently was I was able to click on it and it would highlight the task itself, where I can then update it to clean the garage. Right? Oh, clean the garage. There we go. Now obviously you just saw not like a little bug there, right? But this is what I was able to do in, I would say 15-20 minutes. We'll walk through the code as a little refresher of what this is doing, right? In the very first part of my code, we have a query selector here that allows me to add some functionality to the add button next to the input tag. And upon clicking it, it should create a list item. I then created a, I'm sorry, I got a query selector for the unordered list and assigned it to the variable here, unordered list, which will allow me to grab that unordered list and manipulate it as needed, right? So we can't just like create an element and expect it to appear on our HTML document. We need to be able to grab somewhere where we want to put it. And then below these two lines, we see the actual functionality of the add button. We have the add to do function here. And upon clicking this button, it goes through all these steps. The first one being grabbing the input from the input tag, right? We grab the value that the user added in the search bar. After we grab that, I created an element, a span element, which was going to hold the to-do text. Now, the reason I did this was because if you guys remember Friday night before we called it for the week, I tried clicking this and it also affected the delete button, right? So I had to find a way to separate the edit functionality to just the text itself. So I created an element for the span. And then within there, I added the context that I wanted to add, which was what was given as a value. So I did to do text content, and I added the whatever was in the input tag. And then I added an attribute specifically to the span itself, right? Nothing else. I did to do text dot set attribute. The attribute I was changing was the content editable attribute, and then I set it to true, which then allows me to edit the context of that span and just the span itself, right? Only the span has that. Now, once that span was completed, the next functionality was to create the button. So we went ahead, we created another element. I wanted to create a button. I added its inner HTML, or you can do inner text for it to say delete. If we see here, here's an image, or we could have made an image if we wanted to, but I kept it simple, so I didn't have to look for one. And then after I added the inner HTML, I added an event listener to this button specifically, right? This button needs to have some kind of functionality, which was the click functionality. And then because we are within a function, I had to open up and do a fat arrow function within here. And this function allows me to add the delete functionality to whatever its parent has, right? So how was I supposed to grab the input from the list? Well, I created a variable called list item, and I assigned it the parent node of whatever my button was going to be, right? And I know I'm going to assign this button to my list item, right? So because I know that's what I'm trying to do, I know the parent node will be the list item. So I just went ahead, I grabbed its parent node, right? And then once I have that list item, now I need to figure out a way how to delete it from the unordered list as well. So how do I grab the content of an unordered list? Well, I first got the list item itself. I then did parent node, which then gives me the unordered list, right? We're going another level above. And now that I have that unordered list, I can do remove child, go back down a level, and specify the list item. Does that make sense? Right? Therefore, allowing me to delete the entire list item, and it, in turn also deletes its children, which will be the button itself, because we're adding it to the list item, right? And that's how the delete functionality works for my list. Now, once the delete button has the functionality, I'm able to put it all together. I then create a list item, right? Up above, all I did was create the context of that list item. I have not created the list item yet. It was just a span, if you guys remember. Right, so I actually create the list item now. I append the to-do text to that list item, and then I also append the delete button to that list item. So now that list item has the context it requires, and it has the button itself, which then I can now add to the unordered list as a whole, right? And that's pretty much everything that my list is doing line by line. I'm able to update it. Sure, I'm not crossing it out. If I wanted to, I would essentially come here, instead of adding the set attribute for content editable, I would add another I'll add a different attribute where I can just hash it out, right? That's another method within itself, which we're not gonna get into. But all it would be just changing this functionality right here. Make sense? Too easy? Any questions about the code? The rest of this, to make it appear like this, would just honestly be CSS, which is not a big deal. That's out of the scope of this lesson specifically, right? This is more for the functionality of actually giving it, the ability to do CRUD features like creating, right? The creating part was actually creating the list item itself. The reading was being able to display it on our browser for the user to see, updating it. We're not just hashing it out. We are actually editing the list item itself and then deleting the entire list item as needed. Now, if you wanted to create a functionality to delete the entire list with, in its entirety, that could be another functionality you could add to it. But that's going to be the conclusion for the to-do list assignments. Now we will continue to move forward. All
I
right.
guess just one quick question. So
Yes.
for some sort of CRUD app, it seems like these functions are probably like pre-existing for the most part, because like you do the same thing generally like among websites, the way you interact with a web page. So is it common that there's kind of like a so kind of like how there's Bootstrap for CSS, like is there something similar where normally there's kind of like a repository of pre-existing functions, people will kind of just import kind of like a module into their HTML to kind of reuse on the front end, or not really? You're just going to recreate the same function that maybe many people have done before. That's kind of a weird question, but it just seems like there would be something like that.
There is typically you can find so when you create your app, you're gonna have to create it, like the CRUD capabilities will be in the back end and in the front end. This is my music app, and we'll go to the back end portion of it, and I'll show you how that kind of works, right? So for example, the user itself, you would create models which will require certain fields that it will take, and it'll create that whatever item you're trying to create. Like here I have user, which takes an email. It will give it a token. It takes a username field. What else do we have? we have like, I had a playlist. When I wanted to create a playlist, there's different things that I have to do, right? So here I have the class playlist. This will create an entire playlist itself. This creates just a song, right? And then you give it certain things that it's supposed to take. Like here, the playlist itself takes a playlist name, max songs, and the library. Is going to be assigned to the user. The playlist songs takes a song, and then you have to assign it a playlist. So I have to create a playlist to create a playlist song. And then to actually have the functionality for it to work, we go back here to a different page called the views page. And here's where you see the actual CRUD capabilities. Page is nothing else besides the stuff that I highlight. Here we have a get method. This allows me to grab a playlist. This puts in a get request. So it takes the type of request that you're using. So whenever I'm working with my front end, I would have to specify that I'm trying to do a get request, right? And here I kind of do that on line 26. I'm creating a single playlist. I have to get the type of request I'm using, the user, its library, and the playlist, and then I'm getting the ID, or I'm getting the playlist by ID, right? And this is a version of what a get request would look like. Here's another get request of getting a playlist by ID or by playlist name. Here is a post request, which is like is what we'll be creating. This adds a song to my playlist. So whenever on my front end, I'm trying to make it so it creates something, I would put in a post request, and then I would put in certain requirements. This will require the playlist. So whenever on my front end, I'm coding that I want to create a playlist, I have to add to it, which call it what playlist I want to add it to. And this is where it's going to grab the playlist to add that song to, right? I know this is kind of like boring. Don't worry too much about it, but on the back end, you handle the functionality for your front end to talk to it, right? So on the front end, whenever you put in these requests, they send it to your back end, and your back end receives that request, whether you want to create, delete, whether you want to read something, which like you put in a get request. If you want to delete something, we have delete methods, all right, and then ways to respond, to get an error or not, or if it was successful. If it is successful, you will get which call it a certain other request. Like if you're trying to delete something, you shouldn't get anything back. If you get no response, then that means it worked. So you should get a 204 no contact, which you won't really see, but it's pretty much saying that it's good. If there was an error, it sends back a 404 not found, or specifically, if it's a specific type of error, you can say there is so many of the songs, whatever. But there's a way of doing it in the back end, and then there's a way of doing it in the front end. For example, if I wanted to, where is my playlist? It's on for the playlist itself. Where's that? Utilities. Getting a library. So this is right here, the code for my front end. On my front end, I would want to create a way to talk to my backend, right? Let's say I want to grab a genre, right? If you guys, this code seems a little bit more familiar. This is what we've been going over these last couple of days. Don't worry about the export. That's something else. I'm trying to export it to a different file. But here is the code for putting in a get request for a genre, right? Const get genre. It's an async function, and then I put in the type of method. It's a get request method. The URL. This is the URL to my API and the endpoints. I'm sorry, this is for the Spotify API. My bad. The authorizations, the response, right? So you do that through your front end as well. Let's see. Here we go. This one is to my backend, right? So my API.post request. This is to create a song in my backend database, right? I put in the API I'm trying to get, the type of request, and then the endpoints of my backend, and then certain parameters of what it's supposed to take. Right, it's supposed to take a song ID, song name, artist, album, genre. On my backend, we have something similar to that. Save songs, models, song ID, song name, artist, album. This is the model I created for my song. So whenever my front end speaks to my backend, certain parameters it takes. I'm sorry, I feel like I lost track of what you asked. What was it?
It was more aimed at like and I think you're doing good of painting the context of it, but the reusability of functions that you're writing for handling
Oh,
stuff on the
That's
front end.
what it was. So
Yeah.
you're gonna go through the immersive program, and we're gonna show you how to do this. Right? There's certain ways of doing it with different frameworks. Right? All this I didn't just pull out of thin air. Right? If you go to the documentation for Django, which is a framework you're gonna use for your backend, they have like small little templates of what it should look like. Right? And it's pretty standard across the board for most backend type frameworks where they use things like models. And they'll have documentation for that. Same thing with React for your front end. They'll have like some documentation of what it's supposed to take. Yes, it is reusable, right? So whenever I created my standalone project myself, what did I use as a reference? I used the same code that was taught to us during the curriculum. And then when I created side projects on my own after the immersive program, guess what I used? I used my project that I used from Cobatoon. So you kind of have like templates of how to do it and how to go about it, or you can look up the documentation itself, and other people have stuff out there. So I wouldn't say there's a bootstrap for Django, but there are examples out there if you're looking for it, right?
Gotcha.
And that's why I pulled this up, because you're able to use your prior work, stuff that you use for your portfolio, to kind of build off of it later in the future if you need to reference something. Yeah, same thing with React.
Okay. Gotcha. Thanks.
No problem. Anybody else? All right. So we're gonna go ahead and move forward. That concludes the to-do list. All right, so all web applications. So pretty much every application that you guys use today is a version of the to-do list or a CRUD app, right? So here's a small example of some of the things that you probably use. I don't know what the B is. Who knows what this is?
Like Pinterest?
Is it Pinterest? I don't know. Right, but stuff like WhatsApp, right? It creates a user, a profile, right? You're able to create different chat groups, delete people from your chat groups. You're able to update the name of your chat group, update your picture, update information. You're able to delete chat groups, delete people off there. Same thing with Snapchat, right? So you're putting in a push request whenever you create the Snapchat profile. So when you guys sign up, right, you're creating a user. So you're that's a push request right there. You have the create ability, right? And then that assigns you whenever in the backend is creating a profile for you and the different abilities that you're able to use. You're able to, read the information on your screen. You're able to update your Bitmoji, update your name, update your contact information. You're able to delete friends, add friends. Any app that you can probably think of out there has CRUD capabilities, right? Tutorial help. Who's heard of tutorial help? Yeah. A lot of us, especially if we're like self-taught for a while before starting the immersive program, we probably were stuck in tutorial help, which is what brought you to the Cobatoon or the immersive program in general, right? Here's a small defined term. I don't really like this term, but tutorial help is a metaphysical space where beginner programmers are sometimes consigned as a punishment for flying too close to the sun of learning. It's called hell not because it's full of red walls, platforms you got to jump on, and random plasma rifle crates, but because it has no natural end, right? So especially when we first start off, if you guys start off with stuff like YouTube, you probably find yourself for a while before you stumbled upon Cobatoon, going through never-ending YouTube tutorials of how to build something, whether it was a website, whether it was a video game, whatever it may be. For example, when I tried to create some games before I got into Cobbletoon, I found myself doing these like tutorials on YouTube of how to make a game from start to finish. And you have this YouTube video playing on the side, and then you're coding along, you're making the game, and then you get to the very end of the game, and you're like, I don't know what I just learned, right? And then you try to go back and recreate that, and you find yourself in a spot where you're like, I didn't retain any of that, right? So that is a tutorial help. I don't know why it was put here. I guess just for good conversation. But thanks to Cobbletoon, you will now have a structured path of from start to the end, from zero to hero, of going from not putting hello world on your screen to being able to have a full-on application on a real server out there somewhere for other people to use, right? Build a replica of this to-do list. We already went through that. And that concludes lesson 6, right? Lesson 6. Now, for the real lesson for today, we are about to start lesson 7, which is going to be the Python crash course. So the first week of the FOP is very heavy on front-end, JavaScript, HTML, CSS. Now that you guys got a good idea of how that works, you're not experts, obviously. Like, it is fine. It's the intent of it, but it was mainly to kind of just dip your toes into the water, get you familiar of what everything is doing, what your browser is doing, how the HTML, JavaScript interact, and how it works, and just enough to get you to kind of put some stuff on your screen. And now that we know how the front end works and whatnot, we can kind of move on a little bit to some of more code intensive stuff. We're going to do a small Python crash course. This is not going to make you an expert at Python, but it's going to assist you in the immersive program. The first 2 weeks of the immersive program are very Python heavy. If you guys went through the intro to coding, it's very JavaScript oriented. They encourage people to come in knowing JavaScript so we can teach you guys Python. If you guys know both, even better. If you start out with Python, that's fine too. They're both high programming languages and very easy to read with the English language. So they kind of transfer over. It's only very small differences in syntax. But this little crash course will get you started in coding in Python and start being able to go from JavaScript to Python and familiarize yourself a little better, so it's easier once you do begin the immersive program. All right, unlike some other people who aren't here when they start the immersive program, if they've never touched Python, they're going to be struggling a lot. At least now you guys will have at least 3 weeks prior to the immersive program kind of working with Python. And this will also allow you to go out on your own and start using Python more frequently during your coding challenges, right? One thing I recommend is on your free time, if you're doing coding challenges, which I really hope you are, you change between languages, right? So before, if you know nothing but JavaScript, that's good. Now you can start going back and forth, but you want to be able to complete both in Python and JavaScript. By the end of the program, you should be pretty familiar with both. Once you're done with the immersive program, I do recommend you try to get really good at one language, right? If you start feeling like, what, I feel like I'm more oriented towards, the front end, you can focus a little bit more to JavaScript. If you like the back end stuff and whatnot, then you can focus a little bit more on Python. The reason I say this is because once you get into interviews, you're going to be asked to code in front of people, right? And it's really embarrassing when you're supposed to be coding in Python and you start adding some JavaScript in there and your stuff isn't doing what it should be doing. So I do recommend alternating between JavaScript and Python. And another tip, I recommend you guys do one coding challenge every single day from here on out. If anything, you should have been doing that beforehand. And the reason I say this is because when you guys get into the immersive program, you're not going to do too many coding challenges. You will the first couple weeks because you're learning Python, so they want to give you some exercises where you can go and do on your own and kind of get familiar with the new language. But as you progress through the immersive program, they're going to deviate away from coding challenges and it's going to be more assignment heavy. They will tell you in the assignment, like, now that you complete it, try doing it in JavaScript, which I recommend you do, but most people won't. But as you progress through the immersive program, you're going to get very busy with your, either the curriculum itself, or once you're done with the curriculum, you guys are doing projects. You're going to get very busy with your individual projects, your group projects. And by the time it comes to graduate and you're looking at interviews, right? And you try go do some leak code, it's going to be tough, right? There is a distinct difference between computer science and programming. Are you guys aware of that? If you guys are currently in a computer science degree, or if you have one in the past, or you have one already, you probably know that the science behind coding and programming is different than actual programming itself. And for some reason, it's really annoying that the industry is like this. But what is the best way for them to figure out how good you are at coding? And the fastest way, especially when you have hundreds of applicants, it's by doing a coding challenge, right? So your technical interviews, when you try to find a job, are going to be oriented around leak code, right? They're going to schedule you for interviews, probably gonna be about 30 minutes to an hour, more than likely an hour. The first 10 minutes is gonna be them talking to you, you telling them a little bit about yourself. The next 10 minutes probably gonna be some technical questions, asking you things oriented around programming and whatnot, yada yada. And then like the next 20-30 minutes are going to be coding in front of your interviewer, right? They're going to give you a link if you're lucky, and it'll take you to leak code. If you're unlucky, like I was, they're going to tell you to open up a shared Word document. They're going to give you a challenge, and they're going to expect you to code it on this freaking Word document, right? With no way to test if your code's working, and tell you to solve the problem. So if you have no experience, or little to no experience with coding challenges because you decided to just focus on the curriculum, nothing else, which is fine, you're going to find that the last the couple months that come after graduating are going to be very tough, right? Especially any interviews that come right after graduation, because you have not touched coding challenges in so long. And coding challenges are more algorithm based, right? So it's a lot of data structures and data algorithms, which we'll touch here, and you will touch a little bit in the immersive program, but it's not going to be the main focus, right? The main focus of coding boot camps like CodePlatoon is to teach you the main meat and potatoes of the actual job itself. But the interviews are not like that, right? The interviews they'll look at your portfolio, right? They might check your GitHub. They might ask to see a project during the interview because they want to see your work. But how many people can just follow through a tutorial on YouTube, have some code on there, and then show it off, right? They want to see if you can do the work. So the best way is going to be those coding challenges. And that's what sucks, right? Even mid to senior level programmers are doing the exact same thing. They're doing coding challenges for their interviews. And it sucks. That's the worst part about the industry, is that really big gate to get through from the technical interviews. But you're not gonna get good at technical interviews a week or 2 weeks prior to interview if you're trying to cram, right? So highly recommend, and you'll think back to this if you don't. Like, dang, I wish I would have listened to Roger. Is that do a coding challenge every single day, even if it's just one coding challenge, right? The immersive program is what, like 4 months, give or take, a little bit less, 3.5, right? 30, 60, that's like 90 coding challenges you can accomplish by the end of the immersive program, and you'll be in tip-top shape for your interviews, right? On top of that, you already have your portfolio. So highly recommend coding challenge every single day in both Python and JavaScript, or focus on the programming language that you want to focus on for your career, right? So without further ado, lesson 7, the Python crash course. This is gonna be very simple stuff, right? It's gonna be like, rotate the string, right, in Python. So bear with it. It's just so you guys can start coding in Python and understand the syntax. But it's not gonna be anything crazy or heavy. It's just enough to get you, the reps in. So what is computer science? Computer science is big and it's more than just programming computers, right? Computer science includes subdisciplines like bioinformatics, cryptography, my bad, English is my second language, networking, security, robotics, AI, and much more. What links all these disciplines together? A pattern or algorithm on how to transform information. Computer science translates the science of information in many languages. We learn programming languages so we can express our algorithms, and we will learn Python this week because not about the language, it's about the ability to think algorithmically, a little algorithmically, whatever, man, that word's hard. But yeah, programming, Python it's very heavy use with data, and also uses object-oriented programming. What is an algorithm? A pattern or for how to manipulate and transform information, right? We call it a pattern sometimes because it must work for all cases of the problem and not just one specific case. And you kind of encounter that a little bit during your lead code challenges or your code wars, whatever you're doing, right? They tend to have some kind of edge cases, right? Where they try to test out your code and, your solution might work with the first two solutions, right? But the next three problems, they're failing. It's typically because like you didn't account for what if the array has nothing in there, right? Or what if it exceeds the limit, or what if it added 0, or a number that you're not testing for, or a character you're not testing for, right? Just set a step-by-step set of instructions for accomplishing some task. What is a computer program? An algorithm that is expressed in some specific computer language. We will be writing our algorithms or instructions in Python this week. Running Python locally, right? So you need to have Python 3 downloaded on your machine. For the most part, I believe every single one of you guys in here went through the install test, so you should have it. And if you also went through the alias portion, you should be able to put Python instead of Python 3. You can check if you have it downloaded by typing following in your terminal. Right, Python -- version. All right, Python -- version. There you go. All right, don't worry about that slash prior to it that the slide has. All right, you're gonna execute a file like this. Type in Python and then the name of the file, ensuring that it has the .py at the end of it. You should run it on your terminal. You might need to run Python 3 if you do not have the alias in your files. So if you don't have it, it's no biggie. Don't worry about it. Just either put Python 3 or whatever. Let's open this up. We are on lesson 7. Okay. Follow along exercises. All right, so make sure you guys have an empty file ready to go. I'm gonna go ahead. Oh, I already have one. Okay. Well, let me. I don't want to delete it. Whatever I need. I'm a hoarder. All right. So make sure you guys have an empty Python file. I'll just call. Actually, I'll do it with Python example.py. Let's close it up. All right, so getting user input, right? So how do we ask the user for input? Well, we use the input method, right? Here on our slides, it's not big enough for you guys probably. You see here, we are declaring a variable, and unlike JavaScript, you don't have to use the let or const or var. You just say the name of the variable, right? So here we are creating a variable called favorite animal, and then we're going to assign it whatever comes from the input, right? So essentially the input method, what it does, it prompts the user for information. Within the parentheses that you put inside your input method, you're able to add some kind of string that the user can see when you run the code. And you see that here in our terminal, right? The information that was added within the input method is displayed on the terminal. It says, please enter your favorite animal, and there's a colon. And then typically, it'll have kind of like a bar saying that you're able to type it, right? That allows you to give the terminal some input. Once it receives the input and you press enter, it's going to take the information the user gives it and assigns it to the variable. On line 4, we are printing this string, your favorite animal is the, and then we are concatenating the value that's assigned to favorite animal within it, and then we're adding a period at the end to be able to display this sentence that we see here. Your favorite animal is the panda, right? So once again, we can do something like favorite animal. Let's say favorite language is equal to input. And we have the open and close parentheses here. Are you guys able to see? Should I zoom in a little bit? We'll zoom in. Right. We can put, what is your favorite programming language? Right. And then we put a colon and some space to kind of format it a little bit. Am I in the right area? CD practice examples. Okay. And then we can do Python, the name of the file. And we see here, what is your favorite programming language, right? We're being prompted for some information. We can say JavaScript. And it doesn't do anything, right? Because we don't have any code. But essentially, as you guys saw, by using the input method, we're able to prompt the user for some information. And now, unlike JavaScript, where we do console.log, here's a little bit more English for you. You're able to print something on your console, you use the print method, right? Very simple, just print, and within those parentheses, be able to print whatever you want. We can say, your favorite language is plus, and then, all right, very similar to the example. We're going to print out whatever is inside these parentheses for concatenating these two strings, the your favorite languages and the period, and then adding the input within here. Run it again. What is your favorite language? We're going to say JavaScript. Your favorite language is JavaScript, right? Pretty simple. How to ask a user for input and then how to print it out on your console. Those will be the very first methods you guys are learning. Awesome. Floats and integers, right? So here we see a small example. We see two variables on line 1 and 2, the decimal and not the decimal. All right. A float is what you would call your decimal values. And here we are passing it the float we want to add, right? The number, which is going to be 5. And then by wrapping it around our float, we can convert it into a decimal. And to convert it back into an integer, we use the int, right? Integer, if you guys are familiar with the language, it's the number. All right, so on one, we're converting it to a float, and on the other, it is a, let me put that over here. All right, so decimal is going to be float, not a decimal, is equal to int. All right. Now, one thing you guys are gonna notice, right? There's different ways that we name our variables, right? In Python, which you guys are probably familiar with, is camel case, right? You guys are familiar with what camel case is? All right, so when we write variables, we tend to do something like this, not a decimal, where the first word in our variable is lowercase, and then every other word afterwards is capitalized, right? In Python, because other than in Python, we use snake case, which is similar to how you see here on line 6, where we use underscores between every word to separate the words. All right, it's called snake case. Now, Roger, which one do we use? Does it matter if we use camel case or snake case? It technically does not really matter. It's going to depend on where you are working, right? So whenever you guys get a job and you're working for somebody, they're going to have ways of doing things, of how they code, right? You might be working with JavaScript, but they like to do everything in snake case, so snake case is going to be. Now, for now, just know that typically Python is in snake case and JavaScript is in camel case. How you do it doesn't really matter. Try to alternate between them both whenever you're using the languages, just to get some good habits. If not, it's not a big deal breaker, right? Don't cry about it. It's fine. Right? So we declare our variables, our float integers, and then we can go ahead and do another print method. This is a decimal. And then print again. This is not a decimal. Now, I understand it's very basic stuff, but I recommend you guys code along with me, just so you can get the reps of coding in Python. Oh, my bad. So we see here, an error, right? This is a decimal can only concatenate strings, not floats to strings. So, I can do something like this. And it should give me both, right? This is a decimal and this is not a decimal. Now, if I wanted to concatenate a string with something that's not a string, what you can do is you can wrap it. So the same manner that we were able to wrap our number within float and integers, you can wrap it with str for string. And then we see that there. Cool. Right, essentially, you're just putting a wrapper around what you're using, and it converts it for you. Same manner that we did for float and int, you can do that for string as well. All right, moving forward, strings and concatenating, right? So if you guys remember in JavaScript, how do we concatenate strings together? Well, typically we use the backticks, right? The button to the left of your one. I don't know what it's called, but I'm pretty sure it's backticks, right? You use the backticks, you're able to type in your string, and then when you're ready to format something, you use the $sign before it, open and close curly brackets, and then within the curly brackets, you add the variable you want to concatenate with. All right. Python is different. It doesn't care for that, right? It does what it wants. And this one is going to be a little bit different. So we're going to have here normal is equal to this string is, right? This is straight out of the slides. And fancy is equal to fancy. I'm using single quotation marks and double quotation marks. It doesn't really matter. Typically, you want to keep it the same whenever you do code. But yeah, single or double doesn't matter. And then here we're going to go ahead and print out normal, and this is how we've seen it on the last examples. We're going to add a space here to concatenate normal with the next string, a plus sign, and then we're going to add fancy. All right, this is the method that we were using in the last two slides. Now, if you do not want to do it that way, to format a string, you're going to do it by starting it with F. Right, you're going to do F, which is going to be for formatting. And then you're going to open up your string that you want to format. And then you're going to do the same way that you did in JavaScript. You're going to use the curly brackets too. So you're going to do normal. And then fancy. Right. Here, you do not need to use any $sign. all you have to do is declare that you're formatting your string beforehand with the F, and then afterwards you can format it as needed, just using the curly brackets, no $sign needed. Right? On the terminal, we see both results work just the same. So either one will work. Right? The F prefix stands for F strings, right, in Python. And you pretty much do the exact same thing with just concatenating, but the only difference is on the line 14, we have to manually add the space in there to make up for the lack of it, right? Cool. Casting to string in int. This, you kind of already saw it on my last example. Num to string. You can put in the number 45 in here, and we're going to typecast is what it's called. We're going to cast it into a different type of, what you call it, what's the word I'm looking for?
It's just a different type.
Yeah, it's a different
variable.
type, right? And then here we have string to num. We can do 45. Oh, my bad, not num, integer. All right, here you see I'm putting a string deliberately, right? It's not just the 45. And we can print num to string, print string to num. As it give us the exact same result. Now, if you guys have used this in JavaScript before, you can typically check what type of type is it. So you can do something like printing what we just did on line 2021, but instead you're gonna wrap it around the type. So num to string, and then let's check out the other type, string to num. And when you print this out, it tells you the type that it is, right? Class string or class integer. So if you're ever wondering what something is, or if you want to do a comparison to check like, hey, if this is a string or if this is a num, then do this. If it's not, do that. All right, this is how you do it. Booleans. I'm sure JavaScript has the same term, Booleans, right? So Booleans is going to be your true or your false, right? It is a little different in Python. In JavaScript, whenever you write true or false, you do not need to capitalize, right? You can just go ahead and type in false or type in true. Python is a little sassy. It doesn't like that, right? So this is true. You write it capitalized. This is false is equal to false, right? Small little difference, but if you're ever wondering why it's not working, it's because you're typing it in wrong. You need to capitalize the first letter within it, right? And then we can do print type. This is true. Print type. This is false. And it will tell you that it is a Boolean, right? So only small difference between JavaScript and Python is the capitalization of your true and false. And then you can always check the type as well. Right? Small changes, nothing crazy, right? JavaScript transfer over to Python very well. But those small changes are enough to make your code not work if you do forget it. Basic arithmetic and absolute, right? Now, to do math, right? I don't know why we use such complex words like arithmetic. If we wanted to do some math, right? We could do my sum is equal to 4 plus 6. That'll do your addition. My subtraction, or I guess, yeah. I don't know what's the opposite of sum. Difference? My difference. Man, I'm dumb, bro. My difference, 6 minus 2. What's next? Multiplication. So my product 4 times 6, right? Using the asterisk for multiplying, My quotient, alright, whatever. My quotient is equal to 8 divided by 4. Our dividing is gonna be your forward slash absolute. If you want an absolute value, you can use the absolute, which will be ABS, and then it will return whatever you put within here, its absolute value. So if it's a negative, positive, right? I'm sorry, mainly negative. It'll return to you the absolute value of that argument. And then we can do print. We'll do my sum, my difference, my product, my quotient, and then absolute value. 10, 4, 24, 2.0, and 5. Right? That's how you do basic math arithmetic in Python. Floor division and modulus, right? Who's familiar with floor division?
Isn't that where you round down? So if you have a remainder, you just round down to the whole number.
Correct. Floor 1 is equal to 7 divided by 2. So instead of using the 1 forward slash, you'll use 2 to be able to divide down. Floor 2 is equal to, let's say, -7 divided by 2. I'm actually curious what 43 is going to give me. I've not done this in a while. Remainder 1 is equal to, so modulus. Who knows what modulus is?
It's what's left over after division.
Correct. It is what's left over after division, right? So here, if I were to do 14 modulus 2, it should return to me 0, right? If I do 3 modulus 5, what is this going to return to me? 2, right? I like to think of it as how many times does this number fit into this number? Right? That's a simple way of me thinking about stuff. Save it. Oh, I didn't print anything out. So go and print floor 1, print floor 2, print remainder 1, and print remainder 2. Python. All right, 3, -4. All right, so 7 divided by 2 gave me -4. Blah, blah, blah. The remainder ones, we see it gave you 0 for the first one, remainder 1 gave you 0. And the other one, Eric, gave me 3. Isn't that interesting? I've not done it forever. I don't use modulus often, but yeah, so I guess it tells you how many times it fits in there. All right. And
I thought it told you the remainder though. Maybe it's just maybe I'm betting.
it
late,
will
so
switch this around.
oh yeah, okay.
It
I've
should
been
give
out too
2.
long.
How's it going, Cody? Nice
The
to
other way
meet you.
was
Join
right
us.
though.
Yeah, the other way was right. And Python's wrong, man. Don't worry about it. I got you. But yeah. Cool, right? So if we did the other way around, it would have. Now, moving forward. So the floor division gives you the rounded down result of division, while the modulus operation done with the percent sign gives you the remainder of division. Right. Next, exponent and concatenating lists. Go ahead and comment this out. So power of 2. How do we use exponent? Well, for exponent, it's just like multiplication, but it's going to be 2 asterisks, right? So 3 to the power 2. What is this? Quick math.
9.
9. Yep. 9. And then let's do my list. 1 is equal to 1, 2, 3. My list 2 is equal to 4, 5, 8, 6. We can print out power of 2. And then let's print out my list 1 plus my list 2. Right? So we see here for exponents to use powers, right? 3 to the power of 2 will bring us 9. So we use a 2 asterisk for exponents. And then for concatenated lists, you're able to just do the plus sign, right? Very similar to how we did kind of like the strings. All right, common Python error messages. All right, the ability to read messages and debug code is very important. This is probably gonna be one of the hardest things for you guys the first couple weeks. I know it was for me, right? Especially when you have all this code on your screen and you do not know what the heck you're looking at. You just learned half of it, and now you're getting all these error messages and your computer is yelling at you. Well, what does it all mean? Well, these are the most common ones you will see. EOF means end of file, and you probably forgot a parenthesis somewhere. Right? It happens, parentheses, colons, whatever it may be. Name error, you call something before assigning it, right? So it doesn't recognize what you're trying to call, right? You're trying to use something, but it doesn't recognize that name, that variable, because it doesn't exist since you never really assigned it, right? Syntax error, check the spelling in your file. That's pretty straightforward one. Type error, you're trying to perform some action on the wrong data type, right? Let's see if it still has it on my terminal. Right, so if you guys remember here, when I tried to concatenate the string with a decimal and it wasn't converted, it gave me a type error, can only concatenate string, not float, right? So you're probably adding something or doing something wrong with a different type that you shouldn't be doing. All right, your first nice little walkthrough. We're gonna wait until we come back. It is 6:34. Come back at 6:44. Take a 10-minute break, and then we'll continue with the lecture. All right, let's go ahead and come back. All right, coins.py. We're gonna go ahead and let's see this one. Oh, no. All right, I already have it finished. My bad. This is my working repo. I'm gonna give you guys about 5 minutes to try it out, and then we'll walk through it. All right. Go right ahead. If you guys want to compare values, then what you have to do is like this. Num1 is equal to 5. Num2 is equal to 10. If num1 is less than num2, print true. Else, print false. All right. Oh no. I'll just run it here. So here we see if num1 is less than num2, print true, else print false. So I'm able to compare using the less than or minus than. If I want to do less than or equal, you would use the equal sign right afterwards. And you can do that as well, right? What if we do 6? False. So less than or equals using the kind of like the arrow function, fat arrow function, right? Both to the left or to the right. If you want to check if something is equal to itself, you use the double equal sign. right? It's false there. If we convert this to the same, it's gonna be true. So this is how you check between different items. Less than, greater than, or equal to. Right? You can also check if something is not equal to itself by using the plus, I'm sorry, the exclamation mark and equals. So if it's not equal to num2, then print true, else print false, but it is, so we can go ahead and change it to 7. And it gets be true again. All right. Anyone get to finish it? Yeah. Good stuff.
I made it too complex to
Okay.
finish in 10 minutes.
All right. Let's go ahead and see it real quick. All right, so coins.py. All right, so first and foremost, we wanted to ask the user for some input. I believe you can see the README here. Write a program that asks the user for an integer number of cents from 0 to 99 and outputs how many of each type of coin will represent the amount with the fewest total number of coins. All right, so that means we obviously want to grab like the big coins first, and slowly work our way down until we get to pennies. When you run your program, it should match the following format, something very similar to this. You might find the mod operator useful because we want to get the remainders, right? So whenever we check if the cent amount, how many quarters can we fit into that, right? We want to use a remainder to use for the rest of the cents, and so on and so forth, right? So here is my explanation, right? So we declare a variable here called cents, which we then use it to grab input from the user, and we convert it into an integer, right, to ensure that it's the correct type. So you say, please enter an amount in cents less than $1. We format it with a colon and some space to, it looks nice in our terminal. And then once the input is given, it casts it into an integer. And now that we have their answer, we can actually go into some kind of if-else statement, right? So here, we're going to check if cents is greater than or equal to 0, or if it's less than equal, and it's less than equal to 99. All right, so we're checking for two different types right here. Then we can go ahead and move forward with everything between line 3 and line 12. If not, we're going to return with this not a valid amount. So if it is a valid amount, we want to grab the first numbers first. So we do quarters. We grab whatever is given to us in our input, and then we floor divide by 25. And that should give us the amount of quarters we have. And then we want to grab whatever is left afterwards. So we also have to use the modulus, right? So if you see here, they do modulus equals. So very similar to like in JavaScript, when you have a variable and you want to increase or lower the count of that variable, you do plus equals or minus equals. You can do the exact same thing, the modulus. So we do sets modulus equals 25. And that'll give us a remainder. For example, if it is 79, it should return to us 4, right? Once we get the quarters, we can move on to the dimes, then nickels, and so on and so forth. We grab the dimes and we divide it to the floor with 10. Same thing, we do the cent, and we're constantly just updating what cent is as we go down, right? All the way up to the point where we get to pennies. Once we get all the information we need, we just print out your change will be, and we can format it just the way we want to. Here, as we see in line 12. If not, return not a valid amount. So we can go ahead and do Python coins.py. Let's go ahead and do 97. It returns to us 3 quarters, 2 dimes, 0 nickels, and 2 pennies, right? So 75, 85, 95. We don't need any nickels, and we can just get the 2 cents to make up what we need. And this gives us exact change, right? Simple. Nothing that we're gonna do during the Python crash course will be too difficult. So no need to like overthink it. Typically, if you take a much easier approach, you'll get the answer you're looking for. Okay. That takes care of coins.py. Follow along exercises. All right, so we'll move on to our Python example. Let's go ahead and comment this out. Comparison operators. So this slide is in the wrong area, but we'll fix that later on. So right, so as mentioned before, comparing two different items, right? So we can do num1 is equal to num2, right? So this would check if the values of these two are the same or not. We can actually let's actually do it so you can see what it gives you in the terminal. Num2 is equal to 6. All right. So num1 is equal to num. All right. So 1 being assigning something to a variable, and then 2 being comparisons, right? Here we're checking if num1 is the same as num2. If we want to check if they're different, we would use the exclamation mark before the second equals num2. This will check if they're not the same. If we want to check if num1 is greater than num2, we use the caret to the right. If we want to check if it's less, the caret facing to the left. If we want to check if it's greater than or equals to, we'll use the right caret and equal sign. And then vice versa, check if it's less than or equals to, use the left caret and equal sign, right? We can also test loads for equality. So we can do ABS, num1 minus num2. And then check if it's less than 0.001. All right, now how does it actually look like in our terminal? Where is my CD practice? Oh, I printed absolutely none of this. Jesus Christ. Print. All right. So here, when we did the comparison on line 69 through 76, we wanted to print out the result and we can see what it returns. Right, num1 equal to num2. It was false, right? Same thing with everything else. It's checking and returns a Boolean response to you, right? Line 6 was probably the one that you probably never have to use anyways, but line 76, checking if the floats are comparison or not. So you can compare. What the was? Sorry, long day. Cool. Chaining comparison operators. So keeping num1, num2, we can do if 2 is less than num1 and num1 is less than 7. Let's go with if print it is true, right? It is true. So we can chain them. As they become more complex and whatnot, you can start putting things into parentheses if you need to. JavaScript is very picky about it, so you typically have to do it anyways. But here you can see that we can do both of these just using the and it's no issue, right? We use and, unlike JavaScript that likes to use the double ampersand signs, or the pipes, right? Here, instead of using the ampersands or the pipes, we use either and or, right? More English, right? Pretty cool. Just and or. Logical operators. So mentioned to you guys already. Comparing using and or. These are the alternates of using the ampersands or the pipes. You can also do not, which will check if something is not either true or false. So these are both booleans, right? These are either true or false is what these variables hold. You can do it if it's either true and false, or it's true or false, or if it's not true, right? So here you can use the and or not. Let's check that out. Bool 1 is equal to true if not bool 1, print not true. I don't think it's gonna do anything right now, honestly. Yeah, it's not gonna do anything. Here, let's do for I in range of 5. This is how you do a for loop. One is equal to false. No. Let's leave it here. Oh, false. Oh, I mean, this is a pretty bad example. I'm trying to make up some random example here, but it's gonna be not the entire time because we're checking if it's not what it is, if that makes sense. So it's like a paradox. So I apologize for the example. But you can check if something is not, right? What's a good way of doing it?
Can't you also, use an exclamation point instead of saying not?
Like JavaScript?
Yeah, like I'm pretty sure if you put an exclamation point without a space and then whatever it is, I think it works the same way.
It doesn't look like it.
Oh, alright then.
You're getting confused with JavaScript. I've never used it like that in Python, so if you could, I would have known if I'm being honest with you. But I know you can do that.
What if inside the if statement you put bool 1 equals not bool 1, so it like swaps it
Bool
inside
1.
in? Oh yeah, I guess that's right. Yeah. So then it won't print out every time, right? There we go. Yeah,
Let's try it out.
there's 3 times instead of 5.
Well, it was 4. So range only does up to, but not including, if that makes sense. So it's been doing, it should have been doing 4.
Well, does it start at 0? So 0, 1, 2, 3,
Yeah,
4.
so like, see, the first time it did 4, the next time it did 5. I don't know why. Maybe because what I had here before. I don't know. But the range typically does up to, but not including. We could do something like list is equal to false, false, true, false, for I in range of for I in do this if list no if I not false print why not doing it? Oh,
You have to
What?
put is not. I think.
no.
No.
What the heck? No way. Really? Okay. Well, we learn something new every day. But using not is an option. Not or and either or. All useful for checking stuff is. Biggest thing is just knowing that you don't use the ampersand or the pipes, right? It's nice because it's like I said, it's more human-like in comparison to JavaScript, where it's very picky with some stuff, right? Being the certain syntax that it uses. Here they're chaining the comparison of less than or equal along with the ands or ors. All right, so 17 is greater than or equal to 10, and 5 modulus 2 is equal to 0, then do this or do that. All right, if it's not 17, if 17 is not greater or equal than 10, then do something else. All right, so just knowing that you can use the different types of Boolean operators. Cool. Data flow and if statements. So you guys kind of got already a nice little introduction to that just watching me code. So the if statements, where in JavaScript you have to put them around parentheses, you don't have to do that. You're able to just go ahead and type it out. If num modulus 2 is equal to 0, then do something else or else, right? That's the difference of JavaScript and Python. Very straightforward. If else statements. If you want to use, I don't think they're here. If you want to do more than one, you would essentially do something like this, where if 7 is greater than 4, print 1, elif print elif 7 is greater than 6, print 2, elif 8 is less than, I'm just making random stuff up here, print 3. All right, so if you want to add multiple ones, if else statements, you would use the elif, where if I remember correctly, JavaScript is else if. So here you will use the elif else print 4. All right, this is how it looks like if you want to have multiple if else statements. Slide only have the one. Oh, you can use the elif if checking multiple conditions. Yeah, so that's how you would use the elif, right? Cool. While loops. So doing something until a condition is met, right? So here we have a variable called total score being 0. And while that score is less than 100, we want to do something, which is if we see here, we are adding whatever the input the user gives us, converting it to an integer and adding it to the total score, and then printing that total score. So let's go ahead and do that. So total score is equal to 0, while total score is less than 100. total score plus equals int, and then we do input. Oop. What is your total score? Print total score. Jesus Christ. How do I, why is it not empty? Coming out. Ah, whatever. I don't care. All right, what is your total score? 6, 20, 78, and then it reaches over 100 and it cancels our program, right? So a while loop doing something until we meet a condition, right? That condition being as long as our total score was less than 100, it was going to continue to ask us for input. And then we're slowly incrementing our total score until we reach that 30 condition, and therefore breaking us out of that total, or that infinite loop, right? So what kept it from becoming an infinite loop? The condition, right? I'm sure if you've made this far, you've probably created an infinite loop at a certain point. So if you had an infinite loop, it's probably because the condition that you set or the lack of. So avoiding infinite loops, right? So here we see an example on the while true, print high, right? And at no point in that code are you changing the value or the Boolean to false, right? So it's going to keep printing high. And if you guys aren't aware of how to stop that, while true, print high. It's going to keep going. If you want to stop it, Control C will interrupt your terminal and it will stop it. Right, so Control C will interrupt it all and it'll stop your infinite loop so your thing doesn't bug out. Cool. For loops. Right? So here we have the word apothecary. Man, why? I don't know why Guillermo put all these confusing words for me, man. Really know I'm handicapped. Here we have a normal for loop. So we do for letter in word. Letter is your version of I, right? Where we do like I equals 0 while I is less than like 5, I plus plus, right? For index, typically when we're trying to do our for loops in JavaScript. Just like JavaScript, you can name it whatever you want. Doesn't have to be anything. Here, what do you think is printed out in the normal for loop for letter in word? Anybody?
Wait, can you say that
Each
again?
individual letter?
Oh.
Each individual letter?
Every individual letter. So unlike JavaScript, when we do for loops, it's typically doing like a number, and then we use like the I to get the index of stuff, right? Here it's looping through the entire string itself and grabbing every individual letter and printing it. So I isn't an index. It is whatever you're trying to loop through. If it's a list, you can do for, let's say, instead of a word, it was a list of letters, which were the letters consisting of the word apothecary. And if you loop through that list, you would grab every word when I see that. Word equals apothic. I'm not using this stupid word. Let's say computer. For letter in word, print letter. Python. We're able to loop through the entire word itself, right? Where in JavaScript, we typically we do like a for loop and we're using the I or whatever you want to be, the value and it use that to go through the index of stuff, here it would just loop through the entire thing. Even if it was a list, right? See, whatever. Let's go with fake. Bit smaller. For letter in word list, print letter. You see bake here. Well, what if I want to use an index? Well, if you want to use an index, you can do something like this. It's called index, right? Using an index. So we can do for index letter in enumerate, you have to specify that you want to use the index of whatever you're looping through. And to specify it, you use the enumerate, right? We can print out index and letter. We see here, it prints out the index of that item along with the value of whatever you're looping through itself, right? So for index letter in enumerate word list, I want to print out the index and letter, right? If you don't specify for it to enumerate or for the index itself, right? This can be whatever you want. It could be X if you wanted to, it don't matter. If you don't specify that first value in your enumerate for loop, it won't print out. Pretty sure it won't. Unless I'm wrong. I'm not wrong. For X, comma, letter, right? So if you wanted to grab that index, you can. You just have to do enumerate. But typically, when you do a for loop, it'll loop through the item itself, right? You don't have to do it like JavaScript, or you have to use the index, right? If you guys remember, we're like for I is equal to 0, I less than the word list dot length, right? I plus plus, and then you do word list I, where you have to go to the individual thing using the index. You don't have to do that. You can just loop through it automatically. Cool. So that's for loops. Using range with a for loop. So you kind of saw it earlier for I in range. If I want, you saw it earlier in range of 5. Print I. Right, it starts at 0, and then it goes up to, but not including that number, right? Because we're starting at 0. So we see it gets up to 4, 0, 1, 2, 3, 4, but not the 5. Now, what if I wanted to go in range of the list, right? The length of that list. Well, to get the length of something, you want to use len for length, and then within it, inside of it, you want to use what you're trying to get the length up. And it has a length of 4, 1, 2, 3, 4. So essentially, this will return 4, right? Cool. That's how you get the length of stuff. Whereas in JavaScript, you use the dot length, you put length around it. You saw there too, print word list, I. Another way of getting your stuff without using enumerate. All right. Before I use enumerate, so I can be able to grab every single index if I wanted to. But yeah, cool. Moving forward. Okay, we're actually gonna take. Now we'll continue. We're almost done to the exercise. So that's while loops, for loops, break and continue, right? Break will exit you out of a loop completely, right? And continue will skip over a specified iteration. For example, for nominal range of 1 to 11 would essentially go from, it'll get you the numbers 1 and 10, all the way from 1 to 10. If the number is equal to 5, then I want you to break and then print out the num, right? So it will exit out the loop completely. Whereas on the line below, here it's going to skip over it and continue with the for loop, right? So here, this will only print what? What do you think this is going to return?
5.
You think? Let's check it out. Because it's breaking, right? I range 1 to 11. For I in range of 1 to 11, if I is equal to 5, break,
Oh, it's
And-
gonna,
what's up?
it's gonna, print everything but 5. So it
Correct.
could happen the first time, it could happen the 5th time, it's random.
So, right, it's going through here. It's the number 1, right? Because we start at 1. If this is kind of confusing to you guys or not, here we're able to specify where we want to start on the range and where we want to end, right? So we're telling it specifically, hey, you're gonna start at 1, not at 0, at 1, and I want you to go to up to, but not including 11. So this should bring back 1 through 10. It gets to 1, it's not 5, so it prints it out, right? It did not go into the if statement because it was not 5. So it prints out 1, goes back around 2, it's not 5. It keeps doing that until it gets to 4. 4, is it 5? Nope. So I'm gonna go ahead, continue on. I print it, right? I only print it up to 4. I go back to my for loop, come back to line 100. Is it 5? Yes, it is. So I'm a break. I'm done. The for loop is over, right? I'm not gonna go into line 102. The for loop stops. So because it breaks here, it doesn't print it again. And it only prints out 1 through 4, right? Whereas if this was continue, it will print everything except 5. It will not disrupt your for loop. It'll skip over whatever condition that was, right? If it was 5, then I'm gonna continue and skip over it. And I'm gonna do the rest of my for loop. That is the difference between break and continue, right? So like if you're trying to loop through something until you find a certain condition or whatever, then you can break then, or and if it's not what you're looking for, just continue the for loop. Does that make sense?
Hey, Roger, how does it know where your for loop starts and ends? So like, how does it know, like if you have, is it the indentation? So after print, say after print I, the next line you don't want in your for loop? Like, because I mean, in JavaScript, right, you use the curly braces, curly brackets, but how do we delineate that in Python?
Indentation,
Indentation.
right?
Okay, copy that.
Everything.
Nice.
So once I put that for loop, everything that comes within this for loop is indented, right? When I get to line 100, everything that comes, if I pass this check right here at line 100, then I would it indents and goes within here, right? So it dives deeper into my for loop. If I don't pass this check, it'll continue going on, right? That's why when we were doing the break, right? It gets here and it never goes into line 101 to break it because it did not pass the check on line 100. Nothing up until number 5 passed this check, the comparison. Once I was equal to 5, then I now pass this gate and it's gonna go inside of this code on line 101, and then it runs into that break. But if it's not 5, it's just gonna keep skipping over. Cool. The indentation. Thank you. I think it was Brandon. Nice to see you. It's been a while. Yeah, so That's how it works, the indentation. Cool. One more before we go on break. Nested loops. I think this kind of answers your question. All loops can be nested and data flow logic can be embedded within them as well. So let's actually see this in motion. So we have animals equal to dog, cat, tiger, and then let's do elephant for good measure. I want to loop through this entire for loop. So I'm going to say for animal in animals, print animal. And this should return to me every animal within here. But I want to grab every single letter in all these animals as well. So as I loop through my animals, I'm just gonna go ahead and start another for loop. So I'm gonna loop through, I grab the first item, and then for every item I grab, I want to do another for loop for letter in animal, print letter. Right? So I go into my first for loop. I grab the first item in this top level for loop, which is dog. And then after I grab that dog, I'm going to go into my next for loop and do something with it. So I grab that dog and then I loop through the letters of that dog and I print it D-O-G, right? I now finish this for loop, so it exits out. It goes back to the top level. Well, I already did everything within this for loop as well. So I go into the next one and it just does the same thing too, right? This is how you do your nested for loops. Cool. All right, time is 7:31. Come back at 7:41 and we'll talk about this one. All right, let's come back. So real quick before we break off for the assignment, the number guessing game. Where did I- Oh yeah. So you're gonna write a program that prompts the user for an integer that the player will try to guess. If the player's guess is higher than the target integer, the program should display too high. If the user's guess is lower than the target integer, the program should display too low. The program should use a loop that repeats until the user correctly guesses the integer. Then the program should print how many guesses it took, and it should look something as follows. The assignment, I want you to change it up a bit. Do not do enter the integer for the player to guess. Screw that. That's lame. I want you to use the random module that Python has to get a random number. Now, unlike JavaScript, where JavaScript you do like math dot whatever to use the random integer. I don't use random often in JavaScript. So I don't know. I'm assuming. I think that's what it is. You have to import the module that Python uses for random, right? It's literally import random. Go to W3 Schools and find it. I pulled it up for you anyways, right? Python random randint method, right? So at the very top of your file before all your code, you're going to do import random, right? Python has many files that you can take advantage of, one of them being the random module. So you have to import what you want to use. Therefore, you want to import random. And then you would use it as follows, using random.randint. So random
Oh,
integer.
you're not sharing your screen?
Oh, my bad. Dang, dude. You let me talk that far? Anyways, I can't really know what to say anything to now. Who was that? Mikhail? Thanks, Mikhail. MVP. Yeah, so can you guys see my screen now? You're going to import the random module, right? So like as I said earlier, at the very top of your file, you're going to import the module you're trying to use. Typically, you can import the entire module or you can import specific things from that module you want to use. Just do import random for now. Don't worry about any specifics. And then you use it as follows: random.rand int, and then you would put the numbers between of what you want to use, right? It's in the Python area. I believe you can find it in the module reference, random module. There's a bunch of other ones you can use. You just want the rand int one, okay? Random integer. Use that instead. You guys got like 7 minutes. Go. All right. Okay. Anyone finished? They want to show what they got? If you finished. Radius close to finishing? Okay, cool. Let's go ahead and move on.
I
I'm gonna ship-
mean, I'm finished if anybody doesn't want to show.
So you want to see? Or I'm sorry, you want to show?
Yeah, if anybody else doesn't want to show, I'll show them.
That's fine, Mikhail. You can say I want to show. Go ahead, show us.
Okay.
Thank you for being considerate for everybody else. It's okay to be a little selfish.
Yeah. Okay, you guys seeing it?
Yep.
So I did the import random, and I did the number to guess, and I did the random ran int, and the integer will go from 1 to 20. And then I did the initial tries at 0. And then I have a variable, and then I'm going to take in an int with the input, enter your guess. And I did the while loop, and it's while true. And then every time the while loop iterates, I increment the tries. So the first one, it's going to be 1. And then I said if the guess that the user enters is equal to that random number that's generated, I check to see if the tries is equal to 1. And if you guess it in the first try, it says you guessed it in the first try. Else you're gonna guess in the use the f strings, like you said, guessing the amount of tries that it took, and then I'll break out of the while loop. And then if I check if the guess is greater than the number to guess, and then I give that prompt. So if I run it, let's say 4, it says too low, try again, and I'll go like 10, says too high, go to 5, too low, go to 7, too low, go to 8, says you guessed it in 5 tries, and I can print out the number, the random number to generate. So it says the number to guess is 2, so if I put 2, it says you guessed it in 1 try. And that's it. Yeah.
Awesome.
And
Thanks,
then-
Mikhail.
all right.
Appreciate it, brother. Good information. Good code. Love it. All right, moving on. That took care of the number guess.py. Where are we? Python functions. All right. When programs get longer and logic becomes more complicated, it becomes harder to keep track of everything. Right? Functions are used to manage complexity and increase reusability. Each function should really be one each function should really be in charge of doing one thing. I don't know why. One function for one thing. All right. Easy. So only difference from JavaScript is where you would write function in JavaScript, you write def or define. All right. So that's how you declare your function. Def, you put the name of the function, right? And then open and close parentheses, no curly brackets at all. As you've noticed already, the difference between Python and JavaScript tends to be the colon, right? We tend to use curly brackets a lot in JavaScript. So it's gonna be the colon, and that's it, right? Afterwards, you're free to declare the function that you want. Here we have a simple sum function where we're adding num1 and num2 to get a total, and then we return total. And then we call the function like normal, give it the 2 arguments, and we can print it out, and you see the result at 7. Cool. Function scope. Variables in a function only exist while that function is executing. When that function is done, those variables go away. That means if you declare something like you see here on line 2, where they declare the num variable and assign it the integer 12, you're not able to print num out later because that variable only exists within the scope of that function, right? Which is known as local scope, right? It's only locally to that function itself. You actually see here too, name error, right? One of the errors as mentioned before, where it's not tracking what num is, all right? Because globally, it can't find it. It only exists within the function itself. Default arguments. It's possible to give a parameter a default value if no argument is passing it or it in the function call. We see that here on line 1. Num1 is the parameter we're setting, while num2 is set as a default of 10, right? In the event that you don't give it a value, it'll still execute with its default function. We see that on line 4 and 5. On line 4, we actually give it a value, right? We override the default, which with 5, right? And it gives us 7. But on line 5, we don't override it, right? The default comes into play, which was 10, and gives us a result of 12. So you're able to give your arguments different defaults if needed, right? That tends to come in hand, especially when working with like classes and objects. Doc strings. The doc string is a special type of string you should use to help document your functions, right? It's essentially a comment, right? This doc string should give a description of the function purpose. Use triple quotation marks like the example below. This is how you essentially add commentation to your documents, whatever your code or whatever for other developers or yourself. I recommend you guys try to get used to using it as much as possible. It's very helpful, especially when you guys build your own applications. You're going to go through the immersion program. You're going to get into your individual projects. You're gonna be really proud of it. You're gonna have all this code, like you saw my project, all those files and all that code. That's a lot of stuff to have, man. And it's a lot, especially when you go months without touching it, and then you have an interview, and they ask to see your project, and you don't know what any of the code does, because it's been months since you've seen it, right? And then they ask you to talk through your code, right? Or ask you, where is this happening at? And you spend the next 10 minutes looking like an idiot trying to find it during a real job interview. It's happened to me. Add documentation, right? Add code, comments. It'll help you out in the future, right? Specifically for those reasons, right? Also for group projects and other developers to know what your code says it does. Python student practice hailstone.py. Write a function hailstone that takes in an integer n1 and prints the hailstone sequence. I remember I haven't even looked up the last time I taught this. I don't remember what it was. This sequence takes the name hailstone as the number is generated, bounce up and down to generate the sequence. Follows rules. If the number is odd, multiply by 3 and add 1. If the number is even, divide by 2. Let's look at the readme. Sorry, there's like 3 or 4 months between each class of FOP, so it goes months before I see this code, and I'm like, oh, that's what it was. I haven't taught this forever. Hailstone. Oh, okay. Here we go. So is this on your README too, or I believe I added this? Is this on your README, the first part?
Yeah, it is. I see it.
Okay, just make sure. Uh, a Hailstone sequence starts with some positive integer. You cannot use recursion. So you get Hailstone. Okay, so write a function named Hailstone that takes a positive integer parameter as the initial number of a Hailstone sequence and returns how many steps it takes to reach one. Technically, you could keep going 1, 4, whatever, but you will stop when you first reach 1. If the starting integer is 1, then return the value should be 0. Since it takes no steps to reach 1, we're already there. For example, if the starting value is 3, then the sequence will go so on and so forth. The rule should be up here. If it's even, right? So if it's 1,000, then you divide it by 2 to get the next sequence. So essentially, you're having a loop. You're running in loop until the number that's given to the function reaches 1, right? And you're setting if and else statements. If the number that's given is even, then you divide it in 2, right? If it's odd, then you multiply by 3 and add a 1 to get the next integer in the sequence. My son just came running here. Then use the value you generate to find the next value according to the same rules. Okay, so you're running a loop and you're doing if else statements depending on the rules of the Hailstone sequence until you reach a condition, which the condition is reaching 1. Make sense? Cool. You guys got 10 minutes. Sweet. Yours is good, Brandon. I would appreciate if you could share yours.
Okay, 1 second. Okay, let me go live.
Ooh, you have to zoom in a little bit for us, please.
Yeah, 1 second, my screen's frozen.
It's okay.
Apparently everything froze.
While he works on that, you guys know you guys can use extensions for your VS Code, right? Make it nice and pretty, change colors and stuff. In case you guys were wondering, I know some people are new to VS Code, like coding and stuff.
I had a question, silly, but how'd you get your text to wrap? Mine goes the whole way around. I mean,
What
I
do you
like
mean?
M&M and all, but just the text goes off screen, so I have to scroll the whole way to the side to read everything.
Oh, okay. On your top where it says view on VS Code, at the very bottom you'll have an option that says word wrap. It's gonna be the Alt Z.
I'm an idiot. I definitely looked for that. Didn't see it.
Can you see it better now?
Can you do Control Plus to zoom in, please, just for the sake of us
Yep.
and the people watching? A little more. More. There. Good. Thank you.
Now I can't type for some. Okay, so first I defined a Hailstone function. I set tries equal to 0 in case number was 1 to return 0 as per the instruction. And then while number is greater than 1, I will check to see if the number is divisible by 2. If it is, divide it by 2. Else, if number is equal to 1, I want to return 0. Oh, I actually forgot to multiply. Uh, oh, these indents are crazy.
Don't worry, it's just everybody on YouTube watching you.
I'm gonna get this eventually. Can I not do elif and then else?
You can. Right there. Yep.
Um, damn it. There we go. Okay, that should work.
Yeah. You have to add 1 to it too, it says.
Oh, and add 1?
Yeah, it's 1. Add 1 afterwards. So number multiplied by 3 plus 1.
Okay. Let me restart that. So I'll give it 1, return 0. And then I'll just do 10. Okay, I have an infinite loop going on.
No, 1 should return 1 as well.
Okay, apparently I didn't read the directions
It's
thoroughly.
okay. Thank you for still trying. Appreciate it. Anybody else that was able to do it?
I could try to show it.
Let's go.
All right.
Thanks, Brandon. I appreciate it though.
Yep.
Don't be discouraged. It happens to
not.
the best of us, even me.
It's all good.
All right. Is it? Are you guys able to see that?
Brandon, would you mind stop sharing so we can see
Oh.
Cody's screen?
There you go.
And Cody, make sure you zoom in too, because I know you have that wide screen.
Yeah. I hopefully I fixed it this time. Can you guys see it?
It says you started screen sharing, but it hasn't shown it there yet.
Is it not working?
Mm-mm.
I stopped it. Let me try again. It says my screen sharing's paused, and then I click resume share, and it won't let me share.
Okay, that's fine. I'll share mine. I haven't touched it since last time, so I hope it works. Can you see myself? I think it works.
Yes.
I was really hoping that you guys did it, but oh well. Let's go ahead.
Yeah, I got it, but I didn't want to go again.
Damn, Kel, you can go again.
Yeah, all right.
It's
I
not-
just, yeah, it's really quick.
Okay, yeah, go ahead.
Okay, let me zoom in.
No, you're good. It's perfect.
Going a little bit. So, like it said in the README, if it's 1, you needed to print out 1. So it says you took 1 step right there. And then in the README, it says if it's 3, it should print out this. So if you put in 3 in there, it print out exactly what it wanted, that 10, 5, 16, 8, 4, 2, 1. And it says it took 7 steps. I said it took 7 steps to reach 1. And it said it took 7 steps. So how I did it was I checked to see if it's less than 0. So if it's 0 or less, it will return 0. And if it's 1, it returns 1. Then I have the counter. Then I had a temp variable. I could have just used num, but I just used a temp. And I said while it's not equal to 1. So you can use the exclamation mark in Python. So if it says its temp is not equal to 1, you check if it's even. And to check if something's even, you do modulo 2. If a number modulo 2 is equal to 0, that means the number is even. And it says you should divide it by 2 to get an integer, and you have to do the double, so it truncates the float to make it an integer. And if it's not, then you multiply it by 3 and add it to 1, and then you increment the count. And then I printed out the value, and I did, to get the value in one line, you do the comma and equal to space. So that's how I got it in one line right there. And then I returned the counter, so that's how I got the steps for it. Any questions on that?
And your
Sweet.
line 2, is that less than or equal to? Or
Oh
less
yeah,
than?
so I have it's like linters or something, so it's less than or equal to, and it converts it to that.
Ah,
Because
cool.
I have
Thanks.
some special
Extension.
yeah, extensions in there.
Sweet. Thank you, Mikhail.
Alright.
Appreciate it. Awesome. That's going to include that. We're going to continue trying to knock off as much as we can before we finish class. So that was Hellstone.py. All right, so next, list. Lists are a mutable data structure that has an ordered sequence of elements. Zero index, just like strings and just like JavaScript. Getting elements from list is the same as JavaScript, where you use the index notation with brackets. So example here, our list list of animals. We have dog, cat, and tiger. To get dog, we will use animal list, close, open, close bracket, and then 0 for the 0 index, and whatnot. We also see here another one on line 2. We have a random list, and unlike if you guys have ever used stuff like Java, where typically the lists are of the same type, Python allows you to use different types. Here we have a string on index 0, a boolean in index 1, an integer in index 2, and another list in index 3. So you're able to combine different types within your list. Slicing a list. Slicing a string gives you back part of that string based on the indices for the start and end you have written. And you can do the exact same thing for a list as well. A simple way to remember is R, which stands for like your array, start, stop, and step. So here we have the word hello. We are printing out on line 3 word from 1 to 3. So we start at 1 and we stop at 3. So that prints out our E, right? Because we started at 1. So it will print out the 1. But it doesn't print the 3, if that makes sense. It's up to, but not including, right? So it does index 1 and index 2, but not index 3. So even though it says we're starting at 1 and stopping at 3, we actually include the 1 index, but we do not include the one that we stopped at. Does that make sense? Very simple to like the range. Line 4, we don't add anything to the left side of the colon. So we are saying, hey, start from the beginning, right? We're not specifying where to start. So it's just because it's empty, it will start from the very beginning up to 3. Therefore, it gives us H, E, and L. Line 5, we are specifying the start, but we are not specifying the end. So we are starting at index 2, everything that comes to the right of it. So it gives us LLO. On line 6, we don't specify a start and an end. So it gives us the entire word, hello. On line 7, we don't specify the start or the end, so it doesn't have any words specifically, but we tell it to step over the second ones, right? So we skip over E and L. So we skip over 2, right? So H skips over 2, LO. Cool. And then the last one, which is I'm pretty sure you've seen it used in different types of coding challenges where they tell you to reverse a string. Using the -1, we essentially reverse the string completely. Don't ask me how that works. That's how it works. All right. You essentially tell it to start from the beginning. Make sense? So if you ever find those coding challenges where you're supposed to, reverse the string, this is the easiest way of doing it and the fastest line of code. Cool. Operators for lists and strings. In and not in checks if a value is in the string or in the list, right? So here we have the variable animal and it holds the string anteater, and we say print ant in animal, right? So it's going to check inside of the word the value animal. Same thing here on line 4. We're checking tiger not in animal. It prints out true because it's not in there. Same thing on line 3. It prints out true because it was in there, right? So it prints out whether it was true or not. On line 5, we're trying to find n. This will find the amount of times that n appears within animal. And then we print out the length of animal, right? So find will return the index of set n. Oh, my bad. I got that wrong. I thought it counted the amount. I think count. There's a specified one for count. Let me double check. Python arrays. Count returns the number of elements. Yep. Correct. So find brings you the first index of the item you're looking for, where count gets you the amount of times it appears in that list or word. So you can loop through, find, not in, the same way that you would in list. You can do that on the string as well. One thing to keep in mind, this works almost like a for loop, right? And that will play a part later on once you start thinking about time complexity and space complexity. It's a little out of scope right now for this lesson, but if you're trying to do things in your code with as little as steps as possible, when you use methods like in, not in, or find, you're essentially looping through your list or your string. So it's the same as doing it for a letter in animal and then looking for every single item in there until you find what you're looking for, if that makes sense. Just something to keep in mind for a future lesson to come. Cool. Min, max, sort, and sorted. This works the exact same way as a loop, just so you're aware of what's happening behind the hood. But yeah, so min, max are built-in Python functions that allows you to find the minimum number in your array or the max, right? So here we have odds and evens. We use the min for odds and it will return 1. Find the max in evens and it returns 10. Sort will alter the input list and sort it for you, right? So if you have a list of numbers, it will sort everything inside of it. If it's a list of words or strings, it will sort it from the smallest to the biggest. Sorted will make a copy of the list and sort that. All right, so we see that here. Evens.sort will sort the list for you, but it won't save it if I'm correct. Hold on, let me double check that. I'm pretty sure. And so if I do print evens.sort, it will sort it for me and show it to me. But if I do this, I don't think it will change it. Let me double check that.
I think sort modifies the array and sorted creates a new new one.
Yeah, let's see. Even is equal to. Mm, 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 mm. Print even dot sort. Print even. Okay.
So yeah,
Yeah.
if you did above that line, if you did even dot sort and then you printed even again, it would do it.
Sorted even.
You could even just do sort even and then reprint even. You just can't dynamically print even
Yeah.
dot sort.
Sorted even. Yeah, I didn't.
And
Okay.
and the parentheses.
Oh, I see what you mean. My bad. Sorts. Oops. Sorted even. So this did not print out like I wanted to. Okay, there we go. Sorted even, sort. Okay. But see, here we did. Okay, even, sorted even.
At the bottom, can you try even dot sort and then just print even again?
Okay, so here we got even is not sorted. And then we sorted here, so it's sorted. Here it's sorted too. We print that out. But then we print out even again, and it's not sorted. So even though we sorted it here on line 112, right? And then we print it out later on as well. Let's move that here so we can better see it. Here we called even and we call the method sorted on it. And it did return to us, it's sorted, but it didn't change the list even. It still printed out the unsorted version of it. All right, so it doesn't change it. But if you do print out, it will print out in a manner that it is sorted, but it won't change the list itself. Right? Here, we printed out the sorted version. We reassigned it, created a new list that was sorted, and we printed it out. So it did that successfully. But it had to create a whole new value for it. Here, we sorted again, returns the sorted manner, and it did change it. So the difference here was even though let's see if we do this. Okay, if we print it out but don't hard keep it like this, it won't sort it for us. So that's nice to see of how the effect of it works. Right, when we were just printing it out, but we didn't change it overall, it didn't do it for us. But yeah, so that kind of takes care of that. So now you got to see how that works and how that affects it. Min gives you the minimum number in your list. Max gives you the maximum number. Even though sort allows you sort it as well. Sort it. You can do that to get a new list that is sorted for you. And both of them essentially give you the exact same result except how you call it, right? So if you call it standalone, it'll give it to you and it'll actually change it for you. If you do print evens out sort, it won't change the list for you. It will just give you a sorted version of it, but it won't manipulate it, if that makes sense. Cool. List comprehension. List comprehensions are a concise way to construct a new list by applying some transformation to an existing list, similar to the map method that you use in JavaScript, right? So instead of looping through the entire list and then sorting it yourself or doing something specifically to every single item in that list, you can just do it on a one line. It's a little confusing to kind of see it, but let's read through it. So we have a list here called nums, 1, 2, 3, 4, 5. And then we create a variable called double nums, and within this variable, we multiply every number by 2. And the syntax is as follows: 2 times num for num in nums. Essentially, what this is doing, it's doing a for loop. And then as you go through the for loop, you're multiplying every single item you grab, but it does it in one line, right? This is called list comprehension. So the for loop that you would typically like take 2, 3, 4 lines to do, you could do it all in one line and then just straight up save it into a new variable, therefore creating a list of or a new list of your previous list with the added effects, right? So here we print out double nums and we see the new list with the added effect to it, where every single number multiplied by 2, right? So it's the same effect of just writing, hard coding a for loop. Instead, you do it all in one line while simultaneously creating a new variable and assigning it to it, right? It's the same method of using the map method from JavaScript, but in Python. Only events. So for num and nums, right? If num is modulus 2 is equal to 0, then we add it in here into the only evens, right? Now let's see how that looks like in code. So if I want to do line 3, right? Nums is equal to 1, 2, 3, 4, 5. Normally I would do for num in nums, num times 2, double nums is equal to empty array, double nums dot append, double equals. Right. So what they did here on line 3, I did it in 4 lines, right? They were able to do it all within the empty array, where I had to add an additional 3 lines to do the for loop, create a new variable that's multiplied, and then add it to the empty array that I want to create in, right? They were able to do the exact same logic all in one line thanks to list comprehension. That's all it's doing, right? 2 times the num for the num in nums. So you're essentially looping through the entire nums list, grabbing that number, multiplying it by 2, and then saving it into your new list. Once it's done through the entire list comprehension logic, it saves it into double nums, right? Same thing for only evens. For num and nums, if num modulus 2 is equal to 0, only events dot append nums modulus 2, right? So same logic, or I could do, no, actually that's fine. Yeah, so same logic. The exact same thing they did here on line 4, where they looped through the array nums, grabbed the number, did a modulus 2, and did a comparison to 0. And if it passed, it saved in that list. I did it here in 4 lines instead of 1. That is the power of list comprehension. Make sense? essentially just doing a for loop all in one line. Pretty cool. Powerful stuff. Powerful stuff. Ah, I'm getting tired. Dictionaries. Dictionaries, right? It is essentially the same thing as what JavaScript calls an object, right? A data structure that allows you to store key value pairs. One of the most useful data structures in algo challenges. All keys in a dictionary in Python must be immutable, right? Similar to JavaScript, to initiate a dictionary, you use open and close curly brackets. It takes a key and a value. Here we see Washington as a key, Olympia as its value, Oregon, Salem as value, Idaho, Boise as value, so on and so forth. It is state and cities. I believe it's not capitals. It's states and cities. Is it capitals? Yeah, it is. I'm dumb. I don't know my geography. And then it prints out using bracket notation, right? Just like JavaScript does as well. Cool. I don't think I have to go too much into this. Pretty straightforward and simple. Very much like JavaScript. But this is how it looks like in Python. And how it's grabbed. Adding and deleting key value pairs. So let's actually kind of walk through this because it can get confusing. So we have our state capitals. Washington and Olympia, comma. I'll do 3, Oregon and Salem, and then Idaho and Boise. I know they're not capitalized. Deal with it. So we were able to print out state capitals, grab the item using brackets. So we're gonna go up, grab Washington. What in the heck? Olympia. I don't know why that printed out. Somewhere. It's a Y. Where's this Y?
It's wrapping your .py.
My dog PY.
.py on your file name there. So Python does example
okay.
.p and then it breaks
I
a
see.
line.
Thank you. It was driving me crazy. There we go. So much better. I was like, where's this Y coming from, dude? Yeah. So we were able to grab an item using bracket notations. Now, what if we want to delete something? Well, let's talk about adding first. Let's go ahead and add something here. We're gonna do state capitals. To add something, you kind of just declare it, right? So I'm gonna add Texas. So I'm gonna open and close brackets, add what I want to add as a key, and then assign it a value. It's gonna be Austin. Print state capitals. Washington, Olympia, Oregon, Salem, Idaho, Boise, Texas, and Austin. All right, so I added, it successfully adds the new key value pair. Now, if I want to delete it, I would do del, delete, state capitals, and then what I want to delete. Let's not delete Texas. I like Texas. Ain't nobody like Idaho. Delete Idaho. And we see here, what the heck? Idaho's still here.
You didn't reprint.
Oh, I didn't print it. My bad. Print state capitals. Rookie mistake. There we go. There we go. Idaho, long and gone. Nuked it off the map. Good to go. Cool. All right, so that's how you add and delete. Next is going to be iterating over dictionaries. It's going to be very similar to as iterating over strings or lists. There's just a small little difference. Let's get rid of this, get rid of this, and get rid of this. So to iterate over a dictionary, we can do for let's say key values in state capitals. So if you want to iterate over both keys and values, we would call the dot entries, oh, it's items here,
Items.
items. And then we can print out key and values. We are here, Python. We can see Washington, Olympia, Oregon, Salem, Idaho, Boise, Texas, Austin. All right, so that's gonna print out both key values pairs. If we wanted just keys, we can do for key in state capitals dot keys, print key, and it'll print out just the keys. If we wanted values, we can say for values, it could be whatever you want, I'm just calling it values, in state capitals dot values, print values. And there are my values. Cool. So keys, values, and items, right? JavaScript is entries. That's the only real difference here. If you print out print state capitals dot entries, it'll return to you a list. What the heck? Oh, values. God dang. Oh my god. My bad. It'll return to you a list, right? A list here of what you're asking for. Same thing with keys and same thing with values. All right, a list of what you're asking for. Tuples, very similar to lists, but different syntax, right? They use open and close parentheses, immutable versus immutable. Tuples are a bit faster to access, right? Tuples tend to have fixed indexes. Tuples can also be used as keys in a dictionary because they are immutable. Whereas lists, they use they're different than tuples because they're mutable, whereas tuples are immutable. If you wanted to access something in a tuple, you're able to access it a little bit more directly in comparison to a list because you have to loop through every single one of them. Here we see tuples of numbers, tuples of strings, and then a mixed match of different things. Here is an empty tuple. This is not a tuple because there's no comma, right? Here we have what you call it just a string kind of. And here we are saying that here's the first one and then an empty one. Numbers 3, 2, 1. You can sort them. Oh, you can't sort them. I don't use tuples often. Let's mess around with tuples a little bit. So to my tuple, you don't want to name stuff by what it is. It's going to be 1, 4, 7, and 8. We can do for number and my tuple print num. I don't want to keep going to my console. This is what's the command? I forgot the command. We can loop through it. We can do print. I'm pretty sure we can do my tuple, and then we can do 1. No, you're not. I have not messed with it in so long.
I think
Oh.
square brackets.
Yeah. For how you did it. There you go. So we get one index, we get three. What else? If three and my tuple print in here. Yeah. So if I'm correct, the difference here is if I do F3 in my tuple, it'll get three and go straight to it. Whereas on an array, if you do this, it's gonna try to like loop through it, right? You would have to loop through every single item until you find it. Here, it'll grab that and use it very similar to a dictionary and go to the location of it and grab it, right? Because it's immutable. It's a fixed position. Therefore, the difference here, it would be the time complexity. Only difference between really is the mutability in the access of the information in comparison from a list, right? List tends to have higher time complexity due to that, where tuples, because it's immutable, should be easier. Does that make sense? Tuples can also be used as keys in a dictionary because they are immutable. We already talked about that. Cool. Mutability versus immutability. A mutable object can be changed after it's created, and an immutable object can't, right? So very similar like lists, you can change it whenever you want, whereas a tuple you cannot. Some data types are mutable and some are immutable. Mutable is you can change it, immutable you can't change it. Cool. Count letters. We will do this tomorrow because we're out of time. I was trying to get through this as fast as possible. Let's look at it. How hard is it? All right, it's a dictionary. We're not gonna do today. We'll do tomorrow as a warm up, and then we'll do this nice little assignment that I'm gonna write up tonight, for you guys. But that's pretty much your quick Python crash course. Emphasis on the crash course, right? It's not to make you an expert in Python. It's to give you some slight exposure to it, so you can start kind of writing on the syntax and thinking in a different language. The rest of the week, we'll get some more practice on working with Python all this week, and even a large part of next week will all be Python heavy. Tomorrow, let's look at the calendar. Yeah, tomorrow we're gonna focus a lot more on classes and objects, right? Classes and objects will allow us to make things and kind of like build a blueprint where we can create other things, if that makes sense. Do you guys have any experience with object-oriented programming? Anybody here?
Yes, a little bit.
Yeah, so that should be fun. We'll get to build some small little games and whatnot, very similar to like how you did like a number guess game, but it'll all be on your screen of making like a storefront, asking for input, choosing different options and whatnot. We'll do that all for the remainder of this week, and then next week we're going to use everything that we learned in Python, and we're going to create a small mini game, as I mentioned to you guys before, using Pygame, one of the modules that Python has. We'll create our little Space Invaders game, and you guys can have fun, giving, making enemies and whatnot, adding different, powers to your little spaceship and driving it around and whatnot. But that's going to conclude today's lesson. Very quick, very straight to the point. Try to work on your Python with your different LeetCode and Core Wars, I think that's what it's called, and just get used to the syntax. All today and most of next week will all be Python heavy, so just get used to it. But besides that, we're gonna stop class here, and I'll open the room for any questions if you guys want to stop by. If not, have a good rest of your day.